In our previous video, we observed that EMF is induced whenever there is a change in magnetic flux linkage. We also noted that the magnitude of the induced EMF depends on the rate of change of magnetic flux linkage and the number of turns of the coil. These observations can be summarized in what we call Faraday's law. Faraday's law states that the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux linkage. So, in summary, Faraday's law gives the relationship between the rate of change of magnetic flux linkage and the magnitude of the induced EMF. Another important law that we study in electromagnetic induction is the Lenz law. Lenz law gives the relationship between the magnetic field and the direction of the induced current. It is important to note that Lenz law can be used to predict the direction of the induced current. The following diagram shows various directions when there is an induced EMF in a coil. For case 1, we have an approaching magnet making the pointer of the galvanometer to deflect towards the right. When it is withdrawn, the pointer deflects in an opposite direction. Remember, in the first case, we have the North Pole and as a result, there is an induced North Pole on the coil. When we now withdraw the magnet, we have a South Pole. For the second case, we have a South Pole approaching, and as a result, we induce a South Pole there. The pointer instead now deflects towards the left. When it is now moved away or withdrawn, the pointer deflects towards the right, while there is an induced North Pole on the coil. These observations can be summarized in Lenz law. Lenz law states that the direction of the induced EMF is such that the induced current which it causes to flow produces a magnetic effect that opposes the change producing it. The direction of the induced EMF is such that the induced current which it causes to flow produces a magnetic effect that opposes the change producing it.